right, so the journey we're taking today is, well, it's pretty fascinating. It's about how evolution forces us to choose a partner.
Right.
And then how psychology determines if we can, actually stand to live with them long term.
Exactly.
We're doing a deep dive into these deeply programmed systems that govern that initial attraction. And then, and this is the crucial part, how we maintain those bonds for life. We pulled together some great sources, moving from hard biology right into emotional systems.
And to really get it, you have to start at the bedrock. We have to go back to 1972, to Robert Trivers.
Okay.
He formalized this concept called parental investment theory, or just PI. And really, if you want to know why we choose the way we choose, PI is the answer.
So break that down for us. What is PI in simple terms?
PI is basically any resource, so time, energy, food that's spent on raising offspring and increases their chances of survival.
Okay, that makes sense.
But here's the key. That same investment reduces the parent's ability to invest in any other offspring. And the big insight, the whole game changer, is that this investment is almost never symmetrical between the sexes.
Right, which means the sex that invests less, and that's typically the male, whose contribution can be, very quick, is often free to go find more mating opportunities. While the sex that invests more, typically the female, gestation, nursing, all of it, she becomes the selective one.
Exactly. That asymmetry dictates the entire mating landscape. It just imposes completely different selective pressures on males and females. The higher investing sex becomes the choosier sex.
And the lower investing sex evolves to be more competitive, more eager to mate.
Precisely.
And the foundational evidence for this whole idea comes from, well, not the most glamorous of study subjects.
No, not at all. It comes from the fruit fly, Drosophila melanogaster.
The fruit fly.
Yep. Bateman's work way back in 1948 with marked fruit flies. It gives us, I think, the clearest picture of this asymmetry. He measured two things: mating success, MS.
And reproductive success, RS.
Exactly. And the sheer biological mechanics of these flies are just fascinating. They really illustrate the point perfectly.
So let's unpack that fruit fly reality for a second.
Well, the males have these impressive spiky hairs called claspers. They use them to, firmly attach to the female during mating.
Right.
But the real key to the asymmetry is the female's biology. They're polyandrous, which just means they mate multiple times, and they can store millions of viable sperm in this organ called the spermatozoa.
For days. It actually says it can double the outcome. It sounds like a real challenge for a male fly trying to ensure paternity.
It definitely complicates things for him. But when Bateman tracked the success rates, it just perfectly confirmed what we now call the Bateman gradient.
What's that?
It just means that the increase in reproductive payoff from